10th Physical Science Lesson Classification of Elements. Topic Metals and Non-Metals. The every element in the modern period table was for getting octet position. Octet means 8 electrons. So outer shell must filled with 8 electrons. Then the element getting inactive as a noble gases. For example, third period elements are taken here. First element sodium, atomic number 11, electron configuration 1s2, 2s2, 2p6, 3s1. So this is a sodium atom. So here the electrons are distributed in main cells. Okay, so 1, 2, 3. 3 main cells are there. So here 1 electron is there in the outer shell. Outer shell contains 1 electron. Outer shell means third main cell. So when the sodium donated this 1 electron to others, then here 2 main cells are there and the outer cell contains 8 electrons. Okay, first the electrons 11 is there. So when this 1 electron donated to others, then the electrons getting 10. The remaining electrons are 10 here. So then the sodium getting stability. So octet position is there. Octet means 8 electrons. So the remaining main cell containing 8 electrons, then the sodium atom getting octet position. Next, magnesium. Magnesium atomic number 12, electron configuration 1s2, 2s2, 2p6, 3s2. So here the outer shell contains 2 electrons. So these 2 electrons donated to other element. Then the 2 cells are remaining and outer shell containing 8 electrons. First, the magnesium has a 12 electrons. When donated 2 electrons, the remaining electrons are 10. So the outer shell containing 8 electrons. So this atom getting the octet position and get stability also. Next, aluminium atomic number 13, electron configuration 1s2, 2s2, 2p6, 3s2, 3p1. So the outer shell containing 3 electrons. So when these 3 electrons donated to other element, so the remaining electrons are 10 and the outer shell containing 8 electrons. So octet position it getting, so it getting stability also. Next one, phosphorus atomic number 15, electron configuration 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so here outer shell containing 5 electrons. 1, 2, 3, 4, 5 electrons. So here more electrons are there in outer shell. So now this atom gained 3 electrons from other element. So 5 plus 3, totally 8 electrons are there in outer shell. So first the electrons of phosphorus is 15 After getting 3 electrons, the total electrons 15 plus 3 18 electrons are there, and the outer shell containing 8 electrons, so getting octet position and stability also. Next, sulfur atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. So outer shell containing 6 electrons. So here also gained 2 electrons from another element. Totally the outer shell contains 18 electrons. First 16, next gained 2 electrons, totally 18 electrons are there. Next outer shell contains 8 electrons, getting octet position and stability also. Next, chlorine atomic number 17, electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. So outer shell containing 7 electrons and gained 1 electron from another element. Then here totally 18 electrons are there, and outer shell contains 8 electrons and getting octet position and stability. So here when we see these 6 elements, so first 3 elements are donated the electrons. Next 3 elements gained the electrons from another element. So first 3 elements, they are donated electrons to another element. So the element which donated electrons are called metals, and the element which gained electrons from another elements are called non-metals. Metals, non-metals. Metals are donated electrons to another elements. Non-metals gained electrons from another elements. Okay. So here the element with 3 electrons in the outer shell are called metals. So here we can see here 1 electron, 2 electrons and 3 electrons are there outer shell. So these are called metals. Next, the element with 5 or more electrons are there called non-metals. So here we can see here phosphorus, sulfur, chlorine. So outer shell contains 5 and more electrons are there in outer shell. So they are called non-metals. Next one, D block elements are called transition metals. Lanthanides and actinides are called inner transition elements. The elements which have both metal and non-metal properties are called metalloids or semi-metals. It shows staircase-like demarcation. It separates metals at left side and non-metals at the right side. So D block elements are called transition metals. So in the previous class already we learned about in the modern period table, S block elements, P block elements, D block elements and F block elements. So D block elements starts from 3rd to 12. 3rd to 12. These group elements are called D block elements. So one name is given for D block elements. Okay. So that is transition metals. So S block, D block and F block elements are metals, but one name is given for the D block elements, that is called transition metals. Okay. Next one, lanthanides and actinides. actinoids. So F black elements are there. So these lanthanides and actinides elements are called inner transition metals. So F black elements are called inner transition metals. Why? Because the F black elements is there in the third group. So the name is given transition metals for the D black elements, and these F black elements called inner transition metals. Okay. S black elements belongs to the metals. D black also, F black also, but there is a one special name is given for D black elements, transition metals, and F black elements inner transition metals. Next one, when we see the P black elements, some specialty is there, that is the elements which have both metal and non-metals. So in the P black elements we can see the non-metals. So first here we can see the 6 elements. Sodium, magnesium, aluminum are belongs to the metals, and phosphorus, sulfur, chlorine, so they are belongs to non-metals. So non-metals are there in the P block elements. So left side we can see the metals, and right side we can see the non-metals. Okay, so in the middle metals and non-metals, there is a one staircase elements are there. So these elements are called metalloids. The elements which have both metal and non-metal properties are called metalloids or semi-metals. It shows staircase-like demarcation. It separates metals at left side and non-metals at right side. So here boron, silicon, arsenic, germanium. So these are appeared as a staircase like a demarcation. Okay, so these metalloids separates the metals and non-metals, left side metals and right side non-metals. So between metals and non-metals, metalloids are there. Okay. When we see this modern periodic table, we observe S block elements and D black elements and F black elements are belongs to the metals. Next one, D black elements, third group to 12th group. So D black elements are there. So one name is given, that is transition metals. Transition metals. And in the third group, 6th period and 7th period, lanthanoids and actinides are there in F block. So these F block elements also given one name, that is inner transition elements. Third group F block elements, 6th period also, inner transition metals. Okay. Next one, staircase elements. Staircase elements, boron, silicon, arsenium, germanium. So these are called metalloids. Okay. Next one, metals donate electrons to other elements. Metals donate electrons to other elements. So in first three examples, sodium, magnesium, aluminum. So these three elements donated electrons to other elements and getting the 8 electrons formed around the outer shell for getting octet position and stability. Next one, non-metals gained electrons from other elements. So in the phosphorus, sulfur, chlorine. So here the outer shell of the elements gained electrons from another elements and getting 8 electrons in the outer shell for octet position and getting stability. Okay, so these are about the metals and non-metals.